Hello, my name is Wesley Priest in Mr. Morrison's Period 4 class. The date is March 27th, 2015, AP Physics 1, and I'm going to be doing problem number 46. I'm going to explain how I did it. Let's get started. I'm going to be using the Force Toolkit rotational algorithm to solve this problem, and there are 6 steps. I'm going to go over them. Number 1, first you have to identify the system being accelerated. Then, number 2, you have to define a coordinate system. Number 3, identify forces by drawing a force or free body diagram, include a motion map, and if necessary, draw a component diagram, and also if necessary, rotate the axis. Number 4, explicitly write torque equals inertia times alpha. The A in this case, because there's no alpha button, represents alpha. Number 5, replace change in torque with the actual forces in your free body diagram. And if necessary, write torque equals inertia times alpha in the horizontal and vertical directions. Number 6, substitute numerical values where appropriate and solve for the unknowns. So this is the toolkit. Now let's get on to the problem. This is the problem, number 46. I'm going to read it. A uniform plank is placed with a pivot at its center. A block is placed on the plank to the left of the pivot, as shown in the figure above. A student is asked to place a second block of greater mass on the plank so it will balance when horizontal. Which of the following quantities are needed to determine where the second block should be placed? Select two answers. First, we have A, the mass of the plank, the mass of the plank, B, the mass of each block, C, the length of the plank, and D, the distance from the pivot to the left block. Let's get on to the solution. There's another picture of the problem, but so now I'm going to go over the toolkit. Number 1, we have to define the system, and the system is the plank with the pivot and the 2 blocks, one of lesser mass, the other with greater mass. 2, we have to find the coordinate system. In this case, I'm just going to say that counterclockwise is positive. And number 3, here's the force diagram. On the block of greater mass, there is a normal force acting up and a force of gravity acting down. And where the pivot and the plank meet, there is a normal force acting up and another force of gravity acting down. Then on the smaller block, there is a normal force acting up and a force of gravity acting down. So basically, this right here shows that all the forces are balancing each other out right now. So this is not moving. It's not the acceleration is 0 right now. And I also put these in to represent that from here to so the length from the pivot, from the block of lesser mass to the pivot is L1, and the length from the block of greater mass to the pivot is L2. Now, number 4, we're going to explicitly write that torque equals inertia times alpha. And since this is an unorthodox problem, I'm not going to explicitly follow the force toolkit rotational, but this is the equation that will solve the answer. So it is m, which is the mass of the lesser block, times L1, which is that distance, equals m, the mass of the greater block, times L2, which is this distance. And there is no numerical value, so number 6 is irrelevant. And then here's the solution. Based on the equation ML1 equals ML2, we can see that the variables we need are the mass of the blocks and the distance they are from the pivot in order to solve it. So the correct answers are B, the mass of each block, and D, the distance from the pivot to the blocks. B and D are the answers to number 46.